Maker snack.
Assembling the Mil Mascaras robot. So bot builders, if you've been following along with our tutorials, at this point you've configured your Raspberry Pi on your Wi-Fi network, you've installed software for CircuitPython, and we've got the Raspberry Pi playing sound through a speaker using a Python program. And now we get to assemble our robot and wire things up, which is always fun. So first, take out your purple robot chassis, place it deck side down, and now attach the ball bearing caster wheel, the third wheel, to the front of the chassis. Now the front part is the one that has this bar that goes from side to side. The back, by contrast, has this bar with the very bottom that doesn't touch the two sides. It also has these two legs that point up diagonally. Now frankly, there's nothing saying that the ball bearing has to be in the front. In fact, from an engineering perspective, if I were to code this from scratch again, I'd probably call the ball bearing side the back side. I'd attach it in the same place, I'd just write the code so that it moves in the opposite direction. Because the bot actually rolls a little bit better with front wheel drive, but I coded a real wheel drive bot, so feel free to go back and modify the code sometime in the future if you want as an exercise. Now you might have a different caster, but it should be pretty clear how this attaches. And once your third roller wheel is on, then take out the two TT-style DC motors. And the wires attached to these motors are delicate. Now there are likely zip ties wrapped around each motor to help hold the wires down so it's harder to accidentally pull the wires out. Now if you have those zip ties on your motor, keep them attached, but you want to rotate this little nub where the ties come together so that it's not on the side opposite the wires. That's because the side opposite the wires is going to be mounted flush with the inside of the chassis, and the nub will get in the way. So you'll insert these two TT motors inside the chassis. Now the metal part of the motor with the attached wires will point toward the caster ball bearing wheel at the front of the robot, and the wires on the motors are facing in. They're not pinched in between the chassis and the motor. Now the axle goes through this large circular hole, and then you take your 25mm M2 screws and pass them from the outside of the chassis through the two holes that exactly match up with the motor. The screws are only on the front side of the motor. There are none on the back. If you bought the Adafruit L bracket kit, the only things you're going to use in here are the two longest 25mm screws and the nuts. You ignore all the other parts. Use a nut to attach the screw on the inside, tighten up with a screwdriver, needle nose pliers help too. The motor should be snug, you don't want it to jostle loose, just don't screw this so tightly that you crack the motor plastic. Now you want to pass your two wires for each motor, the red wire and the black wire, from the bottom of the deck through the top of this largest circle at the very back of the chassis, and again, that's the side that's opposite the caster ball. And it's tough to squeeze the two wire pins through this circle at the same time, so it's okay to separate these wires by pulling them apart a little bit so that you have enough play in them to pass them through the hole one at a time. And tweezers can help if you have a hard time getting the pins through the hole. Now another pro tip, I use electrical tape to identify which side of the chassis the motor is mounted to. I wrap some red tape around the right side pair, so red for right. You can label these with masking tape if you want. Be sure to leave enough wire space in the end so you can still tell which wire is black and which one is red. But also label the left side. I'm going to use black electrical tape for that side because you want to distinguish both of these from the third set of red and black wires that you're going to eventually have that are coming from the battery pack that's going to power these motors. Now to make it even tougher to pull the slack wires out, I like to secure the motor wires to the bottom of the deck with a little bit of clear packing tape. Now push your wheels into the axle shape and the wheel hole match up, and then you can turn your bot over and balance it on the two wheels and the ball bearing. Look at that. Now take out your battery pack. This is going to be used to power the motor hat and motors. Be careful, there's a very tiny screw in here too. Now you want to put in 4 fresh AA batteries. Make sure to insert them with the correct orientation. Slide on the cover, use the little screw to keep the pieces together. Make sure the battery pack is turned off. We don't want it on right now. And another pro tip, I find it tough to read the on-off markings on this battery case, so I put a little piece of tape on the side so that I can remember which direction is on. Now I also recommend using a case for the Pi. This way you can mount the Pi using sticky velcro to the case and not the electronics. Just be sure to take out the SD card first, and the Pi snaps right into the bottom of the case, and then you can slide the SD card back in. Then we take the motor hat board and attach it to the Pi, and you'll see that the sockets in the motor hat line up with the pins in the Pi. Make sure that you don't skip any pins and that both rows are aligned. Then push the motor hat board into place. It should fit snugly and shouldn't require too much force if the pins are aligned properly. Next, I suggest mounting the basket first and do that right underneath the ball bearing caster. So I used some double-sided Velcro tape. First get a sense of where you want things to line up, then put the two Velcro pieces together, peel off the back and attach one of the sticky sides to the basket, then peel off the other side's backing and push the basket down so that the sticky side of the other piece of Velcro sticks to the deck. Now attach the battery pack the same way. Be sure to orient it first. You want to make sure that the wires are going to be coming out toward the back of the chassis, and you also want to make sure that the on-off switch is accessible. Now I positioned my battery pack so the on-off switch was a little bit closer to one wheel because I'm going to have a bit of the Raspberry Pi hang off the other side. And it's also okay if a bit of the backpack hangs off the back of the chassis deck too. Next up, orient the Pi before using sticky Velcro to attach the Pi case to the battery pack. Now this build isn't going to use the USB port, so I'm going to face that toward the basket since we're never going to need it. Now we are going to use the micro USB port for power and the audio jack for the speaker. If you orient it this way, you can also reach the micro SD card. When you attach it, make sure that you don't obscure the on-off switch that's on the battery pack. Also make sure that all your wires are going to be able to reach the terminals okay. Mine's going to be a tight fit, but it'll work great. So I'll attach it here. And one of the nice things about using sticky Velcro is it's easy to take things apart if you want to rework the design, or if you want to recycle any of these parts into other projects. Next, use a tiny flathead screwdriver to loosen up the terminal screws on the motor hat, and I'll show you how I screwed in the wires one by one, but I initially got the wiring wrong. So here's what the actual wiring setup should look like. Now this diagram is in our step-by-step web instruction document at gallagher.com/Mil-Mascaras. Here's the diagram labeled for easy reading, while underneath there's a picture of my final wiring. Now the left motor red wire goes into MB2, the left motor black wire goes into MB1, the battery pack red always goes into VIN, and the battery pack black always goes into GND. The right motor red wire should go into MA1, and the right motor black wire should go into MA2. So these read red, black, red, black, red, black from left to right. Now it isn't unheard of for the orientations to be different in different motors. If you find your wheels are turning the wrong way, this is what I suggest that you do. First turn everything off, then unscrew the wiring and remove the wires for just one of the two motors. Then you can verify that the right side wheel is on the right side. If not, then you can switch the A's to the B's and the B's to A's. Now, if you find that any wheel is turning in the opposite direction, backward is forward and forward is backward, then you can switch the black and red wires for that particular wheel. Just never switch the middle pins for VIN and ground. Those should always be coming from the battery pack, red into VIN, black into ground. So here's another look at the correct wiring after I went back and corrected things, after I got the app running and found out that my bot wasn't moving properly. So it's wired up just like the diagram that I showed you. It's tight, but it works great. And now let's add the speaker. So plug it in first because the wire on the speaker is very short, and then make sure that you can reach the on and off switch once the speaker is stuck to the basket. Now if you mount the speaker using sticky Velcro tape, you can always peel the Velcro off if you can't reach the charging port in the speaker, but if you can make both the switch and the port accessible, even better. Now next, plug the mobile phone battery pack into the micro USB port in the Raspberry Pi, and while the AA battery pack powers the motors and the motor hat, this battery will power the Pi. Now it's a bummer that we have two batteries, plus we have a rechargeable speaker. It would be nice if we had a single power source and a single on-off switch, but that would require much more sophisticated electronic works and some soldering, so we'll live with multiple batteries and multiple on-offs. Now as far as the mobile phone battery goes, you might be using a battery with different dimensions, but mine fit nicely with two strips of Velcro that I cut from the standard width. I attached one to the front of the chassis, the other to the bottom front of the basket. I pressed in my battery, and it fits nicely. And I used a bread bag style wire to wrap the excess battery wire to the basket and keep it away from the wheel. So bot builder, your robot is looking pretty sweet, and remember we've got 3 on switches for motors, speakers, and for the Pi, but our build looks great. Feel free to power everything down for now, and in the next video, we'll program the bot we just built so we can get things moving. Hope you're feeling good, 'cause you're building something awesome.